Starting with finding the F prime. F prime, you see the product, right? This is the product. When you see the product rule, you treat it as a product. And with the negative square root 5 as a common factor, just take it out of the parentheses and then apply the product rule. To use the product rule again, to be safe, make sure we don't mess up with anything. I'm gonna put on the side where I identify as the U and the V. So this is my U and this is my V. So the U equals square root x and the V is natural log quantity 2x. The U prime square root x is x to the power 1 half. U prime is 1 half x to the negative 1 half, or we write it as 1 over 2 square root x. And then the V prime, the natural log of the quantity 2x. This part you're going to use the chain rule. The first layer or the outer layer is natural log. It's going to be 1 over the quantity behind the natural log and multiply by the derivative of the second layer, which is 2. And then simplify to be 1 over x. The prep work, simplify as much as you can before you bring it back into the working area. This is my recommendation. If you follow, that's good. If you don't, you have your own way. I'm okay with that too, as long as you have all the terms and you are okay with your algebra. Okay. So from the product form, product rule, u v prime plus u prime times v, that give us the negative square root 5 out front. The u is square root x. The v prime is 1 over x. The u prime is 1 over 2 square root x. And the v is the natural log 2x. And what we have to do next, simplify the inside, the parentheses here, bring it into one single fraction is more convenient when you have to work on the next part, which is the second derivative. Unless you want to keep it this way and then you have to do the derivative term by term, you can do that way too. It can be done more than one way, depends on how you want to manage your problem. Okay, so for this we can as you see the first term square root x and x here, you can simplify to be square root x. That's the common square root x here. That means the common denominator would be square root x and then multiply by 2 because I see the extra 2 here. So the first term now becomes 1 over square root x. And the second term, which is the natural log of the 2x divided by 2 times square root x. The common denominator, 2 square root x, make the first term to have the same denominator. So multiply 2 top and bottom. And then the numerator, the first term is 2. The second term is the same as the natural log of 2x. Then I can see the number 2 here can be outside to join square root 5. So negative square root 5 over 2. Inside, I have 2 plus the natural log of 2x divided by square root x. And this is my f prime. And our goal is to find f double prime to identify the concave up, concave down, correct? Still more work to do here. Question on deriving f prime. No question. All right, next one, we're gonna find f double prime. I see this as the fraction form. I'm gonna make the top as a u, the bottom as a v. So the u is 2 plus the natural log of the 2x, and the v is square root x. the u prime, the derivative of the 2 is 0, derivative of log 2x, we just borrow what we found in the earlier part. See, if you keep track of the thing, you can reuse the common thing as part of the process. So it cut back your working time. So the u prime is 1 over x, and the v, which is square root x, the v prime is 1 over 2 square root x here. Now, put them together to get the f double prime with the common factor negative square root 5 over 2. The quotient rule, which is vu prime minus uv prime over v squared, or the denominator times the numerator derivative, which is the u prime. That what we get is 1 over x, and then plus, not plus, sorry, it's minus sign. The u, which is the quantity 2 plus natural log 2x multiplied by the v prime, which is 1 over 2 square root x, divided by the v squared. The v is square root x and then squared. Next, simplify. We have negative square root 5 over 2, nothing to do with that. And the denominator, square root and square, that becomes x. I'm going to take it out my way to be 1 over x out here. Okay, as the same technique, you divide means you multiply by the reciprocal. So then the numerator, this part, square root x over x, is the same as 1 over square root x. I'm going to write it as 1 over square root x subtracted by the quantity 2 plus natural log of the 2x divided by 2 square root x. It's similar form as what you saw in the f prime. I mean, not exactly the same terms, but you have the common thing as what you saw in the previous part the problem. Next part, clean up as much as you can or simplify, rewrite it as one single fraction, because the one single fraction gonna help you find the the number that make the f double prime 0 and the number that make f double prime undefined, same way as when you did with the critical value. So I combine these two products into one fraction as negative square root 5 divided by 2x. And then in the parentheses, I see the common factor again, as 2 square root x. So I multiply the first one by 2 over 2 and share the same denominator as 2 square root x, and the numerator 2, negative sign, that's another algebra part that you have to pay attention. So 2 minus natural log 2x, 2 and 2 cancel. Then we have negative sign times negative sign here become positive. So positive square root 5 times natural log of the 2x divided by 2 and 2 becomes 4, and then x multiplied by square root x as the second derivative in one single fraction form. Okay, question. It's a lot of algebra going on. Just be careful every step that you use any algebra property. Next, we're gonna find the possible inflection point by looking at the case at f double prime equals 0 and the other case f double prime undefined. The case at f double prime equals 0 is the case that the numerator equals 0, or the square root 5 times natural log of the 2x equals 0. For the undefined, the denominator is 0, or 4x square root x equals 0. Solve each one, divide all by square root 5. natural log of the 2x equals 0 raised to the power of the e. So e to the natural log of the 2x equals e to the power 0. E and log cancel. We have 2x equals 1 or x equals 1 over 2. Let's see, I have more room. No more room. Okay, and then the next case gonna be x equals 0. X equals 0. Now we have two possible inflection points. The possible inflection points that we found earlier from f double prime equals 0 and f double prime undefined, they are x equals 0 and x equals 1 over 2. So x equals 0 is not in the domain because the domain, the restriction here, x has to be strictly greater than 0. So then it's come down to only one possible inflection point. Okay, so locate 1/2 over here. And to identify the sign of f double prime, I would use the same analysis as what I did in last section with many problems. The f double prime is in the form of, let's see, the form of the square root 5 times natural log of the 2x divided by 4 times x square root x. So I'm gonna identify one by one the sign of each one of them. The square root 5 over 4 is always positive, so we don't have to worry about that. So look at the sign of the natural log 2x and the sign of the x square root x. Okay, the natural log of the 2x, any number, for example, at 1/2, the natural log of 1 is 0. For the number greater than 1/2, such as x equals 1. If x is 1, the natural log of 2 times 1 or the natural log 2 is greater than the value 0. You can verify using the calculator. So the sign on the right side of 1/2 for the natural log gonna be positive. Any number less than 1/2, for example, you pick the number 1 over 4. Natural log of 2 times 1 over 4 or natural log 1/2, the sign comes out as negative. So the left side of the 1/2, the natural log 2x will return negative inside for you. Similar way as we analyze with the x, for the x times square root x always positive because we consider anything greater than 0. You put the positive number in there, positive number in there, you always get positive sign. It doesn't matter less than 1/2 or greater than 1/2. Does it make sense? So you divide these two quantity. That means you divide these two signs. Again, I should not put too many. So then the sign, after you divide negative and positive, the final sign gonna be negative. For the positive divided by positive, you get positive. That tells you the interval, negative sign, I'm not happy, right? If I'm not happy, upside down. The positive sign, I'm happy, right side up. That means the interval of concave down is between 0 and 1/2. So we can summarize it as the interval of concave down is from 0 to 1/2, and the interval concave up is 1/2 to positive infinity. Goes all the way to the right end. And since the sign switching from negative to positive, that means the inflection point occurs at x equals 1/2